Okay, so now this is going to be the third part of the binomial lesson, and the most important formula, actually, the one that really is a huge shortcut. So it's going to be the expected number of successes for a binomial distribution. So it's an expectation situation. So let's say x is the number of successes. Well, my handwriting was terrible there, but x is going to be the number of successes. So let's say we have one trial. So only one trial. So we're going to make an XPX table. So XPX, XPX. So the number of possible successes, if you have one trial, is you could either have 0 successes, or you could have 1 success. And the probability of having 1 success is defined as P. Remember, P is the probability of success for a binomial distribution. And the probability of no successes is the same as the probability of failure, which is going to be Q. And then 0 times Q is 0, and 1 times P is P. And if we add them up, we get that the sum is P. So the number of successes we expect from one trial is P. Okay. Now let's say we had 2 trials. So we're going to make an XPX table for that one. Ta-da. So here we can have 0, 1, or 2 possible successes if we have 2 trials. So the probability of success is going to be P times P, which is going to be P squared. And this one's going to be Q squared. This one can either be P times Q or Q times P. So it's going to be Q plus 2. Either way, it's going to be 2PQ. It's going to be PQ plus PQ. So we multiply these, we're going to get 0, 2PQ, 2P squared. And we add it up, and we get 2P squared plus 2PQ. And I'm going to common factor out at 2P. So what's going to be left there is P, and then we factor out the 2P there, we're going to get Q. But what does P plus Q equal to? P plus Q, of course, is 1, right? The probability of success plus the probability of failure is just 1. So that just becomes 1. So that's going to be 2P. And I could do it for 3 trials as well. So I'll kind of do the setup. If you had 3 trials, it would be... I'm not really going to prove this one over here. Did I just mix up the colors I did? I did. So it could be 0, 1, 2, or 3, and the probability here is going to be Q cubed, P cubed, 3 Q squared P, 3 Q P squared. And I'll leave that as an exercise to the reader to show, not the reader, I guess, the viewer, to show that the sum ends up being after... Actually, let's do it. It's going to be 0. This is going to be 3 Q squared P, 3 QP 6 QP squared, 3P cubed. So we're going to get 3 Q squared P plus 6 QP squared plus 3P cubed. And I'm going to factor out 3P, and that's going to give us Q squared plus 2PQ, 2QP, plus P squared. And this over here, if you remember your grade 10 at all, this factors into Q plus P squared, and Q plus P is 1, 1 squared is 1, and that just gives us 3P. You don't really have to know that one. I was just showing that for fun. The point of all this is that, so for one trial, we had 1P successes. For 2 trials, we had 2P successes. And for 3 trials, We had 3p successes. And if you could guess, if we had n trials, it turns out that we would have np number of successes, which essentially is the formula. So the EX, which is the expected number of successes in a binomial distribution, is just equal to n times p. Let's do an example of that. I'm going to have to use the back of the paper because I'm out of papers. Okay, so I forget what example number we're on. I'm just going to say 5. A bag has 7 red and 5 blue marbles. We're going to draw a marble, note the color, and replace it. Why are we going to replace it? We're going to replace it to make sure the probability stays the same so that it's binomial. We're going to do this 20 times. Do this 20 times. And the question is going to be, how many blue marbles do you expect? And so what we have is, we know that, let's say we're going to say that success is going to be draw a blue marble. And n is going to be 20, and the probability of success is, so there's 5 out of 12. And the probability of failure is this, but it doesn't really matter because since it's binomial, the expected number of successes is just going to be NP, which is going to be 20 times 5 out of 12, which is 100 over 12, which is going to be 8.33. Now, we're not going to actually round that number. What this means is we expect to get 8.33 blues. That's how many we expect to get, right? We don't... It's kind of like when we had that wheel. So remember back in the other lesson, we had a wheel and you could win $0 or $300. What do you expect? You expect 150. Are you going to actually get 150? No, you're not going to actually get 150, but you expect 150. In this situation over here, we expect 8.33 blue marbles. And that's expectation.